Hello YouTube, and welcome back to Kind Heart Homestead. My name is Ben, and I'm up here on our off-grid property in the mountains of Virginia. It was snowing just yesterday, but today it's warmed up and we finally have some sun. So I spent the morning doing some renovation work over at our apartment complex. And I'm also in the middle of working on Cedar's clubhouse. If that video is not out yet, it should be out pretty soon. So I'm splitting my time between several different projects. We're also trying to get the garden, which is just beyond this fence, ready for the spring planting. What I'm doing now is trying to take inventory on all the materials for our chicken coop. We still have two 4x8 sheets of OSB subfloor locked away in the shipping container. I'm going to need Angie's help to carry those because they're very heavy. But today I'm going to worry about the framing. Basically, before we can install the subfloor, we need to build a small 8-foot by 12-foot frame on top of some skids. That's what we're working on today. And a skid is just a fancy word for, I guess, those things that go underneath a sled. We're going to use two 4x4 posts. You probably can't see them, but there's a pile of lumber over here. And I think the 4x4 posts are going to be roughly the same length as the building, but they're going to be like this. So if we ever need to pull it with a tractor or something, we can. Go back a couple years on our YouTube channel if you want to see us do that before. We have a nice plastic shed that we assembled from Costco, and it's on a framed platform with, I think, T111 as the subfloor. We had some material left over from a workshop project, and I put it on skids, and we've been able to move that around no problem anytime we rent a machine, whether it's a track hoe or a skid steer. I have plenty of chains and ratchet straps, and we've been able to move stuff around that way. That's what I would like for this chicken coop. So you'll hear me probably call it a semi-permanent structure. It's permanent in the sense that we're using conventional framing techniques. We're going to have our wall framing 24 inches on center, aligned with the roof rafters. The floor joists are going to be made out of 2x4s, and because of the small dimension of the lumber, we're going to do 16 inches on center. There's no permanent foundation or concrete going into the ground, and we'll be able to move it on skids. So I'm going to build it here just on the other side of the fence from their existing portable coop, or I should say semi-portable, because I don't have a forklift and there's no wheels. So one thing we've done in the past is I'll take the legs off and put it on a truck or a trailer and move it around, or I could put it on a pallet, strap it to the pallet and pull it around. We have all of this stuff in previous videos, so I'm not going to spend too much time talking about previous projects. I'm just trying to give you some reference as to where I got some of these ideas from. But the most original idea for this chicken coop is something that I found on YouTube just a couple weeks ago, and it's the concept of having a human foyer before you get to the chicken part of the coop. So we're going to have a 4-foot by 8-foot foyer room that we can step up and go inside of. We can stand full height. On one side, we'll reserve a space for like a brooding box area, like for chicks. We're going to get another flock of meat birds this year. If our hens ever go broody, we can put them in there to sit on their own eggs to stay away from the rest of the flock. And then on the other side, we'll have room for our feed bags and our totes where we mix our feed in bulk. We make our own organic feed out of bulk seeds and grains and things like that. So that's really the premise. But again, today I'm just going to start on the platform framing. So stick around if you want to see that, and I'll be right back.
I chose 8-foot by 12-foot for this design because lumber comes in both of those lengths. The width is 8 foot, and when you buy 8-foot lumber, it's going to be pretty close to 8 feet. Not always exact, but these boards are actually pretty close. The only issue, though, is that because there's going to be a rim joist on either side, that's the 12-foot lengths, I actually need to cut 3 inches off of each of these. That's because each rim joist is 1.5 inches thick, and 1.5 inches times 2 is 3 inches. So you can do the math and figure out however many inches 8 foot minus 3 inches is. But basically I have to cut enough for the entire floor system, and then there's going to be two 12-foot rim joists, like I said before, that go perpendicular and that's what all of those joists in between are going to mount to. I took out my miter saw with the stand because it makes it a lot easier to do duplicate cuts. I have a handheld circular saw, but when I cut that close to the edge of a board, it makes it a bit tricky because the weight of the saw tends to knock the board off of whatever I'm using. So having a mounted tool is a lot easier. So now that the joists have been cut, it's time to move on to those 12-foot rim joists. The first thing I need to do is see how long they are, because if they're not exactly 12 feet, that's going to be a problem for my design. The next thing is to establish the layout. So there's going to be a joist on each end, obviously, so I can actually measure 1.5 inches from each end, but then I'm measuring 16 inches on center for each of the interior joists that you won't actually see at the end, but they're just as important as the outside ones. And 16 inches on center means that you're measuring from the center of each joist to the center of the other. If you put a tape measure and measured 16 inches between the two, then that would be beyond 16 inches on center. And that's not very good if you're using sheet goods from a typical hardware store, because those come in 4-foot by 8-foot dimensions, which are evenly divisible by 16 inches on center. So basically, when you're doing carpentry, you're subject to the dimensions that the industry provides. So in my case, 16 inches, 24 inches, 48 inches, and any multiple of those numbers is what I'm shooting for in this design. So that's enough about the concept of layout. How do I actually do it? So I make those measurements and I draw a little arrow where the tape measure shows the numbers. And then I go back to each of those arrows that I drew and I transfer the measurement fully across both boards at the same time using my speed square. The speed square is really handy because it has a little lip that hooks over one side of the board to make a perfectly 90-degree line. And this small speed square happens to be the perfect length to go across two 2x4s. They do make larger squares for larger boards. So now we have layout drawn on the rim joists, and we have the actual joists cut to length. So we're pretty much ready to start assembling the floor system for this new chicken coop. What I like to do is lay the rim joists out first so I can kind of estimate the spacing for the joists. It just saves a few minutes so I don't have to stand up and grab each joist out of a pile. They're already there and they're all within an arm's reach of where they're actually supposed to go. But those layout lines that I drew allow me to see exactly where to nail these. And I'm using galvanized nails that are 3 inches long because they're not going to corrode like a regular nail would in the pressure-treated material. Now it's time to move on to the skids. I basically have to draw the exact same layout as the rim joists because these are going to accommodate every single joist, and I have to know where those are going to be. And instead of setting these on top and tracing them, which would transfer any inconsistencies in the lumber, including bows and warps and things like that, I'm actually going to draw the layout just like I did before so I can force it into the position I want it rather than accommodating the inconsistencies.
All right, everyone. I'm trying to race the weather because it's supposed to snow later this week. We have this nice, warm, sunny morning, so I'm going to try to process the skids. I need to notch where every single one of those 2x4 floor joists is going to sit. And then I'm going to try to mount these underneath that whole thing. So I'm going to have to lift that up. And that way, if we ever have to move it, the whole piece is going to be locked together because all of those joists are going to be sitting inside of this. And instead of doing a bunch of parallel cuts with the circular saw and then chiseling it out, I think I'm going to try out my trim router and see if I can remove maybe about 1/2 inch of material. That should be plenty to get this all attached. And I'm going to use some hurricane ties to finally attach that to these skids. So let's get started.
Before I get out the router, I need to actually cut these to length. As you can see, there's a pencil mark about 1/2 inch away from the edge of this, and I need to cut these down to 12 feet just to make everything nice and consistent. And I mentioned before that I typically have issues using this tool on the very edge of a board, but I'm able to approach this from two sides, and these are pretty heavy boards, so I'm not too worried about them flipping over under the weight of my saw. I'm really just struggling to get into a good position to make a very clean cut. And if it's not the best cut in the world, it's not a big deal because this is just going to be in contact with the ground. It's not actually needed to terminate any sort of joinery. I'm moving on to the other board now, and I'm doing the same technique. My blade's not actually deep enough to cut all the way through this in one pass, so I have to go through one side, flip it, and then go through the other. Now it's time for the router. So you might see some confusion on my face because this is actually the first time I've attempted this. I'm struggling to calibrate my router to be the exact depth that I want. It's not a very intuitive tool for raising and lowering the bit, and it's possible that I don't even have the right bit for this. This is probably more meant for whiter wood or maybe some sort of trim pieces, but this is wet pressure-treated wood, and I'm really afraid of getting my hand or my shirt snagged in this bit. So you can see I went ahead and got a clamp out, and I'm clamping my speed square down, and I had to measure off of the bit to the edge of that little clear plastic guide because I want to cut right on the line. The square can't go all the way to the line because of that distance between the bit and the plastic. So anyway, once I figured that out, I started slowly riding the bit through, and then after I completed one pass, I was able to carve out the rest of the material freehand. And now I have to replicate this technique for the remaining 9 joist areas, which is easier said than done. When you're on the edge of the board, you only need to worry about one side of the cut because you can freehand the other side and there's nothing there to mess up. But for these interior joist areas, I have to use the clamp, run the bit down one side, move the clamp to the other line, run it down to the other side, and then freehand the material in between. So I'm about to show you a close-up of the finished product. I'm going to let the results speak for themselves, but I would say this is way better than chiseling, at least because I'm not an expert in chiseling. So now that I've perfected this technique, I'm able to easily replicate it to the other skid. I'm working my way from one end to the other using the exact same technique. Basically, I clamp it so I can run the bit down the left line. Then I remove the clamp, move it to the right side so I can run the bit down the right line. And then I freehand the material out of the middle before I remove the clamp. And then I move on to the next one. And now I'm cutting 45-degree angles off of this board. These angles allow this to act more like a sled, so if I ever pull it, there's no front edge to get gouged into the earth and prevent it from being moved. So now I'm simply lifting up the floor system, moving the skids about 1 foot from the edge. I don't have any rigid bracing to keep this thing square, so I had to grab a sledgehammer to persuade it into place. Basically, I'm using that 1 foot guideline to make sure all of this is symmetrical and square. And I even had to get out a Harbor Freight ratchet strap to pull the end boards into place because there was a bit of a bow and I needed some persuasion to get them into the notches that I've already cut into the skids. Now I'm quickly installing some hurricane ties with correctly rated nails. Now it's time for the joist hangers. Those galvanized nails that I shot earlier through the rim joist into each of the joists, those are essentially tacking this into place, and it will keep it attached long enough for me to finish everything I need to do, but it's not a very good permanent solution because they could pull out. These joist hangers are a very good perpendicular connection with lots of nails.
Well, tomorrow is our snow day. It's very dark and dreary, pretty ominous. I can tell conditions are starting to deteriorate. But since we already got all of our OSB subfloor out of the shipping container, I think it's an appropriate time to go ahead and glue it and screw it and nail it to the joists, and then maybe we can just cover it with that tarp during the freeze. I got some pretty cheap construction adhesive, just liquid nails. It says it guns easily in extreme temperatures, 10 to 100 degrees Fahrenheit. So I'm going to trust them that I can apply it in this weather. It's barely above freezing. I went over to the apartment this morning and got a bunch of tools, and now I'm ready to work. So let's start installing the subfloor.
You'll see me juggling back and forth between a couple different nail guns through this project because these two nail guns take different angles of nail clips, and I'm trying to use up nails from my old workshop project when we lived in Raleigh. You can go back through our YouTube page and find that project. It's a multi-part series just like this one. But these are, I think, 2¼ inch nails, and they're galvanized ring shank, which is perfect for subfloor and going into pressure-treated material. Again, galvanized nails are required if you're dealing with that treated lumber because they're treated in such a way where the chemicals infused into that lumber are not going to deteriorate it over time. For some added rigidity, I'm using that subfloor adhesive. Well, in this case, it's just generic construction adhesive, but at a larger scale, when you're building a larger home, you can buy an actual project called subfloor adhesive. This should work just as well for this application. Basically, I'm gluing just enough for the next board. I stand it up, drop it down so the glue doesn't get everywhere. I don't want to be sliding this all over the place, disturbing the glue. But then I have to use a sledgehammer and a beater board to lock the tongue and groove together. If you don't do that step, then the board is actually going to be wider than 4 feet, and it's going to stick off the end of your project, which is probably fine if you're going to have a pretty rigid flooring, but we are using linoleum, and I don't want any gaps. And finally, I hammer any proud nail heads before moving on to the linoleum. So this is actually my first exposure to linoleum flooring. I'm doing my best to follow the instructions on the adhesive, which includes having a very dust-free subfloor. And the thing I struggled with the most here was trying to figure out how to make the linoleum flat when it came rolled up from Lowe's. So what I'm doing now is weighting it down with a bunch of boards so it has time to settle in the sun.
All right, everyone, it's mid-February. We wanted to have this chicken coop in place so the chickens would have a nice, large, warm place to roost in the winter. Needless to say, we're not achieving that goal, but this has been sitting there for well over a month now. And the reason I can't make any progress on it is because the step that we're missing is gluing down the linoleum flooring. If you recall from the previous clip, I glued probably like 16 inches or so. It's not sticking. And it's not really much waste because that was just the bottom of a bucket that I had left over from a previous project. Now I have a brand new bucket that I need to open. And the instructions do say that the material, all the material being glued together, needs to be at 50 degrees for 24 hours. Well, last night the low was 50 degrees. And the subfloor under there should be nice and dry because the linoleum has been in place. All of this was covered with snow and ice for weeks. So obviously that wasn't warm enough, but it's finally warm enough now. And we're in between rain showers. So I'm going to hurry up, set my phone to time lapse, and try to knock this out in one shot. Because I can do framing in freezing cold weather if it's just a little bit at a time. I can dress up, get the air compressor out, get all my power tools. But this glue, this is the only day this winter, it seems, that I can do it.
Gluing linoleum to the subfloor is pretty straightforward. Just follow the instructions on the bucket. I'm using a notched trowel to evenly distribute the glue, and then I have a fancy roller tool that allows me to put all of my body weight behind it and really lock it down onto the subfloor. The wall framing is going to sit along the perimeter of the linoleum, really anchoring it down onto the subfloor. The glue is really just there to prevent it from wrinkling.
All right, everyone. This is the day we've all been waiting for. Chicken coop day. We had one warm day earlier where I was able to successfully glue down this linoleum. It's been sitting like that for well over a week now. Just cleared off the lumber, got my tools out, and my little helper is here today. I'm trying to teach him safety with power tools as well as proper safety gear. We have safety glasses on him, and he's going to have ear protection as well. So we're going to get started on this, and my goal for today is to get the 2 long walls. Those are the 12-foot walls, and they're going to be short height-wise because they only carry the bottom of the gable. So these are going to be approximately 6 feet tall, but measured from the bottom of that. So I'm going to have to do the math and figure out how long to cut the studs to. That shouldn't be too difficult. Once I figure out that number, we can cut them in bulk.
So to get started, first we removed the weights, which is essentially just some 8-foot and 12-foot 2x4s, evenly spaced across the linoleum, just to keep it nice and dry and intact. And now, very similar to the layout for the skids, we're measuring the total length so we can draw our lines. The lines are going to indicate exactly where the studs go on our bottom plates, and we're also going to transfer those measurements to the top plates. So I am sharpening my pencil to get things ready while Cedar kind of has fun with his little tape measure. So I'm trying to explain to him how to crown a board, basically sighting down using what the Perkins Brothers builders call the laser eye. That's where you kind of sight down using your eye as a guideline. And if you're looking in a straight line, you can pretty much tell which way the board is bending. And that's called a crown in construction terms. You're also looking for warp and twisting and all that stuff. But these boards are pretty straight, but I do want the bottom plate and the top plate to crown in the same direction because that really reduces the amount of curvature the wall has when you're looking at it as a finished product. It's better if they both bend the same way. Cedar's using his tape measure, and I'm showing him how long these boards are. These are supposed to be 12 feet, but usually from the mill they come slightly longer, so I am drawing a bit of a line at the end that I'm going to use to trim the board to the proper length. I make sure Cedar is standing back far enough so he doesn't get hit by the sawdust, and then I approach the board with my circular saw to make the cuts. I do like to use my speed square to make sure I'm cutting at 90 degrees. Cedar really loves to help me with whatever project I'm doing at the time, and I'm trying to explain to him the importance of accurate measurements and tracing lines, transferring measurements, but of course he doesn't really know what I'm talking about. He kind of quickly gets bored with what we're doing and would rather play, but I made it clear up front that this is an important project. We need somewhere secure for our chickens, and maybe one day we can even grow our flock. So I'm trying to keep him a bit interested. His tape measure is nearby. I can't always use his tape measure as well as mine because mine is a bit sturdier and mine's designed for framers, and it has those 16-inch on-center measurements, things like that. In this case, I am using 24 inches on center, so it doesn't really matter. But as you can see, I transferred the measurements from one board to the other, and I spread them out. That way, both bottom plates are pretty much symmetrical, but I also need to transfer it to the top plate. So I'm essentially making 4 12-foot plates, bottom, top, left, right, whatever you want to call them, that are identical. That way everything lines up in the end. Here's some duplicate footage from a different angle that shows what we just accomplished. But once I transfer all of those measurements, you can see it's time to start framing out those walls. So it's important to have well-marked layout where all the studs are going to be secured from the top and the bottom. That way you know exactly where to shoot the nails. You can see here I'm using my air compressor. I don't need galvanized nails for the white wood. I'm just using standard 3-inch framing nails. And I do need to brace it this time because when you stand a wall up, if it's not braced, it's likely to collapse. A triangle is the strongest geometric shape, so one diagonal brace is all I need. There's no need to make an X or double up the bracing, anything like that. But I do measure across the diagonals until both measurements match. When they don't match, I find whatever the longer measurement is, I go up to that corner with a hammer or some sort of block, and I persuade it a bit until they match. Only after that do I brace it, stand it up, and in this case, I can't make the wall perfectly level, or I guess you could say plumb in this case because it's a wall, because the platform is not plumb or level. It's just sitting on the ground, whatever the terrain is. So I'm doing my best to measure 90 degrees, and that's going to be a theme throughout this project. As long as everything is square with the materials that it's touching, parallel with the opposite wall, then it's good enough for me. So here I am attaching some blocks to around the outer perimeter of the rim joist so that when I put the end walls up, they'll pretty much be in line with the lumber underneath. And the reason I have to do that is because I'm not standing up the front and back walls. You'll see in a minute why there's a gap. Obviously the front is going to have a door, but the back also has a trap door, which we're going to use to shovel out the wood chips annually using the deep litter method. So this is similar to how you might frame on a slab if there's like a bathroom door or something. You're going to have an interrupted bottom plate. You don't want to necessarily get a saw out and ruin the flooring if the concrete's going to be your finished floor. In this case, the linoleum is the finished floor, and that's already installed under the wall. So I can't just run the plate long and cut it afterwards without risking damaging my waterproofing layer. So you can see here I have a double 2x6 header, which is going to support a center stud, which will then support the ridge beam. So that's why the header is important. It is structural, and the ridge beam is also going to be structural. And it's actually going to be my first time using a ridge beam of any kind, so I'm kind of excited to do that. You can see here I'm installing a essentially floating rafter that's going to connect the two long walls together. And this is exactly 8 feet to match the bottom. And that's basically my only method of making sure that these walls are perfectly parallel, is by measuring that 8-foot distance at the top and the bottom. In the background now, you can see I am using my layout lines to assemble the second wall on the floor, just like I did with the first wall. And once I match all the layout lines with the studs, it's just a matter of using my regular framing nails and my nail gun to secure all the studs. I can tell you in hindsight that I accidentally fastened one of these boards to the wrong side of the layout line. And that's one reason why you should always draw a layout line on both sides of this stud with a big X right in the middle. Even though I did that, I just was careless, wasn't thinking, and nailed it in the wrong one. But it wasn't too hard to correct later. All I had to do is remove that nail with the cat's paw on the back of a hammer, and I just got it out, re-nailed it. This is white wood, and these are not ring shank nails, so these nails are very easy to remove. It's really the weight of the roof that's holding all of this down, and some hurricane ties will prevent this top plate from ripping off in the future. This brace is actually in my way, so I had to take that off, hold this kind of in the air. I'm using a screw bucket to hold up the other side, just because with that back wall in place, this wall is actually too long for the floor. Only after I stand it up can I shimmy it over another 3.5 inches past that back wall and get it in place. I do have some blocks secured to the rim joist again, and that gives me a positive stop to push this wall out to make sure it's in place. I'm tacking it to that 8-foot rafter on the back because it's pre-measured. I know exactly 8 foot at the top and the 8 foot at the bottom makes it parallel. In the front though, there's no rafter yet. But that's it for the walls. I'm not going to tackle the front until I figure out my door design. But here is a preview for what we're going to tackle on the next episode. Check out these heavy-duty roof rafters made out of reclaimed lumber. So I'll catch you back here next time on Kind Heart Homestead.